Physical evidence, significance and value of physical evidence. As I mentioned in the last slide about class and individual characteristics, the fact that we have most of the items in our homes have been mass produced means it's harder to determine the probability of a class characteristic match. We all have a great deal of the same things. So if you find one manufactured item in our home, that doesn't necessarily mean a whole lot. There's not a lot of individual characteristics to be had, and even just having that one thing doesn't point to us. If you find an iPhone at the scene, and I don't know what number we're up to right now, so let's just say it's an iPhone from 4 years ago at the scene, by itself, lacking any other information, that doesn't tell you a whole lot. Lots and lots and lots and lots and lots of people have that exact same iPhone. Even if you were to take that iPhone apart and see what's inside of it, all the iPhones are basically the same. If you find a sweater, a pink sweater, V-neck sweater at Target at the scene, maybe it belongs to the victim or the suspect, who knows? But Target makes millions of that same sweater every year. So just because you find fibers from a sweater at the scene or a paint chip at the scene, if it came from a very popular car, it might not be terribly meaningful in and of itself. For this reason, because any given class characteristic might be so ubiquitous in the environment, matching class characteristics and multiplying them out by the product rule is extremely important. The more class characteristics you can assemble that all point towards the same place, even if they only point roughly towards the same place, the better the likelihood is that they're all pointing towards the same individual. Changing demographics can also make class characteristics more challenging. This is especially the case with biological evidence. If you had a neighborhood who was largely made up of Scandinavian people and you found a coarse, curly, short black hair at the scene, it's going to be pretty unlikely that it's from somebody from that neighborhood. If the demographics of that neighborhood change, so you have more people of African descent in that neighborhood over time, and you find that same hair at the scene, that becomes a lot less meaningful. Keeping up with demographic information in a neighborhood can help you determine at least a little bit what the case might be. Databasing materials can help. Primary endeavor of forensic science is to keep updated materials databases. We're going to take, basically what that means is we're going to take all these class characteristics that individually mean very, very little and put them in a database. When you run tests on those class characteristics, even if you have a hard time coming up with something to meaningfully compare it to, you should at least be able to find something in the database to see if it matches something in that database. If it doesn't match anything in that database, then you have the opportunity to submit that evidence into the database so that other people can reference it in the future. Multiple types of evidence are produced at every trial and at every scene, you should also say. The statistical likelihood of the evidence pool will increase based on how many individual pieces of class evidence there are. Physical evidence is not infallible. Just because you have a lot of evidence that points to one person does not necessarily mean that that one person did it. The more evidence you have, the better. Largely what you're working with is class characteristics. So as we saw with the product rule, the more things that you can multiply together, the better the shot that you have to point toward that person, or at least the more confident you can be in your assertions. The evidence needs to be presented in context with eyewitness accounts, confessions, and informants, etc. Juries and judges are expected to lean on physical evidence and objective evidence much more strongly than eyewitness accounts and confessions, but unfortunately they are quite compelling. Juries find them quite compelling, and they can lend information that you simply can't find with physical evidence. If nobody was around recording somebody shouting, "I'm gonna kill you," well, then kind of all you have to go with is eyewitness accounts and bystanders. Finding evidence and identifying evidence, comparing class evidence is still subject to human interpretation and bias. I can't stress enough that every single thing that we observe in our world comes through a lens of possible misinterpretation and definite bias. It's our job to try to identify these biases as best as we can and minimize them to the extent that it's possible. Class characteristics can corroborate events with evidence, as we talked about in the last slide. This is like marrying testimony, bystander accounts with hard data, with the stuff you actually find at the scene. Hopefully, identification of class evidence can be relatively free from human interpretation, especially if there's an abundance of reference data that's data-based. Ditto with human bias. When you're identifying any one class characteristic with the same thing that you have that's already thoroughly databased or that you have on hand and are relatively confident they could potentially be a match, and you do proper analytical techniques using proper protocol, there can be a lower error rate on false positives. If there is a positive match, again, that does not mean necessarily that they are a full match, where the fact that one class characteristic matches with another class characteristic, therefore this one individual did it. You need a lot of those combined to reasonably paint that type of a picture. But if they don't match, there's a very, very low chance of having an accidental false positive that indicates somebody might have done something when they didn't in fact do it or were not in fact present. Improvements in detection technology sometimes can be unhelpful. So as I mentioned before, having really, really specific, finicky kind of technology can be really helpful in creating very, very specific results. Unfortunately, if they become too specific, you're not going to be able to determine what's what quite so easily. So whenever you mass manufacture an item, there's going to be some extremely small amount of variation between these individual items. Let's pretend this is 4 panes of glass. They're generally going to be like a silicate with a little bit of maybe like boron or something in it, let's say, right? But you might find it full grits of sand, like full pieces of sand accidentally that haven't melted down completely, that's mixed in and will be distributed at random throughout the glass that came out of that factory at that time. If you have shattered glass and you take a sample and it has that contaminant in it, you may have a test that's so sensitive that it can't basically smudge out the fact that it has this manufactured allowed contaminant in it. It may then come up with a false mismatch where it says that these two things aren't actually a match when they are in fact the case. When you're analyzing different materials, you should be very careful to make sure that your test is specific enough to get the results that are meaningful, but not so specific that it'll find the minute atomic level variations that exist in every single thing and call things a mismatch when they perhaps are not. Individual characteristics, as we mentioned, are better and are really the best practice for corroborating events with evidence. Unfortunately, there is a low likelihood of finding good enough markings or a high enough number of individual markings. Another drawback, so there's standards for class characteristics, right? You can refer to the manufacturer, you can refer to databases, you can refer to a standard reference, you can refer to all of these things to corroborate the identity of a class characteristic. Individual characteristics being what they are, you don't have any of those things. And therefore, there are basically no standards for what constitutes a match. This is left to be an extremely subjective process, unfortunately. There's a high degree of variability and subjectivity, and the individual variation may be accidentally confused with the natural variation, the small, minute atomic level variations we were talking about in the last slide that will occur between any two otherwise identical things. So we kind of have a double-edged sword here, right? On one hand, Class characteristics aren't really anything meaningful in and of themselves individually, but a lot of class characteristics, accompanied by a robust database and a good standard reference sample, can become, because of the product rule, very, very meaningful. Individual characteristics are really your gold standard for identifying something. If you have a really individual characteristic on the bottom of a shoe and the shoe impression you found has that exact same weird variation to it, highly unusual variation, then that's a great indicator that those two are a definitive match and belong to one person. But interpreting how close of a match those are in reality is extremely subjective, and it's entirely left to the eye of the beholder to really make that comparison. Now, there is technology that can help pick out these individual characteristics and statistically quantify the extent to which they vary from the rest, but these don't have as robust a scientific backup as perhaps we might like. There was a study back in 2009 called Strengthening Forensic Science in the United States, A Path Forward, and this was put forth by the National Research Council, a division of the National Academy of Sciences. This was put in place by the Obama administration to help apply scientific rigor to the forensic sciences, which a great deal of the forensic science techniques, unfortunately, have been developed in the anecdotal method that we've talked about before, and developed by police officers at police stations using reproductions and unscientifically derived information to come towards a very scientific sounding conclusion. This was a push to try to apply science to these and really put them to the test and give them the rigor that they deserve and that victims of crimes deserve. What this report determined was that determining class characteristics itself is too subject to human subjectivity, and it has an insufficiently scientific basis and should be inadmissible. The original determination of those class characteristics, you have everything in the world to compare it to, you have things databased, the actual comparison itself still boils down to a person looking at two different things. It can be quite robust if a human being is looking at one item and comparing it with a lot of the same type of item, and it seems to be a match by a bunch of different things and multiple parties agree on it, there's a pretty good chance that it is in fact a match, and it's a really good way of going about that. But it's not been subjected to any kind of real scientific rigor or any kind of standardized protocol by which one might deliberately omit biases from the observer. And they put forth a proposal that there be research that helps reduce that human subjectivity, and methods are determined to help eliminate whatever bias possible. Some work has been done in that arena by universities, particularly those with large forensic science departments. Unfortunately, though, a lot of that funding dried up and this organization dried up during the most recent presidential administration.